Okay, so we're going to take some time and look at center of gravity, center of mass, centroid of a body. Now, in theory, you should learn some calculus, but I'm going to look at it from a statics perspective or mechanics materials kind of perspective. And it's funny because the books will usually say something like, we just are going to assume that everything is small enough so that gravity is constant. And you're like, yeah, thanks. I probably wouldn't have wanted to solve it if it wasn't. Anyway, so in statics, hopefully you remember we had that the itty-bitty force times the centroid is going to be equal to the itty-bitty moment. So we did this when we were talking about distributed loads. And that gave us that the centroid of, or wherever we would put that force, so basically it was like, if we had this, and that was supposed to be a beam, you can't really tell, but we had a function on a beam, and we wanted to replace it with exactly one force at exactly the right location, and basically we would say, we got these itty-bitty s, so that meant we had dm over df, which gave us something like this. So hopefully you remember doing something kind of like this. Maybe remember this from statics? Well, it's the exact same thing, which is pretty funny because we get into this and we're like, oh, look at all these things we're going to learn, but they're all basically the exact same thing. So if we're, say, in 2D, we would say, okay, so the way that this looks in 2D is that instead of df, we would have dA. So it'd be centroid dA over all of the a's. Or if you're looking for the y centroid, it's little y part dA over all the dA's. And if you're like, I came to this video because I wanted actual examples, not just formulas, I'm going to give you one. So if you want to go ahead and pop to that, you can. But basically, you're going to see the same thing in 3D and like with density and stuff like that. So for example, if we have something in 3D and it's homogeneous material, the only thing that we're going to change is we're going to add a volume. And so instead of being dA, it's d volume. Now, if density actually varies, then instead of calling it d volume, then you're going to actually just say d mass. Okay, and then it's just divided by, integral dm. And then the y and the z are the exact same thing. And then the same thing happens if you want to go by weight. If you want to do these by weight and by mass, ends up being the same thing because we decided, right, that gravity was the same across, because you would say, oh, so that means that this is, if I took the previous one and just multiplied the top and the bottom by g, I've got this, did up deep dm, and multiply both sides by g. And so if I put in x tilde g dm and just g dm, GDM is in fact weight. So I would just do put up d weight over total weight. Okay, and then again, the same thing for y and z. We can also do this with composite bodies, but in composite bodies, instead of using integrals, we're doing summations. So like what I just wrote, instead of having the integral x d omega over integral d omega, you would just say, I'm going to sum all of them. So like a way you'll see that written is over all the i's in the system, I'm going to do this times the weight of I over the sum over I of all the weights. So for example, you might say x1 w1 plus x2 weight 2 plus x3 weight 3, all divided by weight 1 plus weight 2 plus weight 3. Now, if at any point that you're trying to remember, like, what am I dividing by, and it might not be weight, it might be times mass or times volume or times area, is you think, okay, like, what are the units? So, like, here on the top for the x, I have, that would be in, like, say, inches, and the weight would be in pounds, and then inches and pounds plus inches and pounds, and then you're like, am I supposed to divide by the w's or am I supposed to divide by the x's? And you go, well, what am I trying to get? I'm trying to get a centroid. Oh, so that means it needs to be inches. That means I need to divide by pounds, so I can end up with inches. And so I always end up having to have that conversation with myself because I'm like, wait, am I supposed to be divided by the x's or supposed to be divided by the w's? And I'm like, oh, it's the w's because I want to get rid of the pounds and end up with inches. Okay, the fun, of course, is in the actual details of getting this to work. So I have this kind of long set of instructions that just, I don't know, it helped me think through this because some people just have this brain that can process this and they're like, clearly it's this. And I was always desperately trying to figure this out. So I kind of wrote out my own little steps that I can work with and be happy. Okay, so here is the process. So So they kind of don't make a ton of sense unless you're actually looking at the problems, but I've kind of written this out. So basically you're going to find the dA. And in order to do that, you have to label like, am I going to itty bitty the x or am I going to itty bitty the y? Then you're going to actually calculate the area, or not calculate the area, just going to write the integral in terms of x or y. So a lot of times you'll have like part of it in terms of x and part of it in terms of y. So the idea is to get the whole thing in x and y. Then you're going to actually do the calculation. And then this is very important. Okay, and I don't mean this stupidly. I mean this for realsies, because like this is like an emotionally devastating calculation until you get good at it. Once you get good at it, you're like, I can't believe this ever gave me a hard time. But you almost need like this moment to be like, you did a good job, way to meet minimum expectations of attempting to start this problem. Because you're only halfway done with the problem and your brain can kind of go, blah. So take a moment, appreciate what you did, give yourself some love. All right, and then the next thing you're going to do is you're going to figure out, based on that itty bitty area, where are the centroids of that itty bitty area? Now I'm saying x and y and a dA. Obviously, it could be x, y, z and dv. Or if you're only needing x, you only have to do x, etc., etc. And then you need to, again, these might be in terms of both x's and y's. You need to write it all in terms of one variable, then do the integration and divide it by the area. But for me, getting the area first is always a really good first step. Okay, so I'm going to solve this problem in two different ways. I'm going to solve it the happy way first, and then I'm going to solve it the obnoxious way. Okay, so the happy way to solve this is I'm going to randomly pick a dA. So itty bitty, what you do is it's area. So this is along the x-axis, so that means that this distance here is dx. It's dx wide. It's itty bitty x wide. Okay, that never looks like an x. Derps, derps. Itty bitty x wide. All right, so the area of that is going to be its width, which is dx, times the height. And the height of this is, it's this tall, right? It's this tall. And that's just y. That's just straight up y. It's y tall. Okay, it's dx wide and it's y tall. So times y. Okay, so that was the first step. That's the drawing in the dA. Okay, now what it says to do next is to write the integral dA in terms of either all x or either all y. So like I kind of said, we've got a y and a dx. So literally I just took what was written here and I wrote it here instead of that. I just made a direct substitution. dA is y dx. All right, so I can either put everything in terms of x or I can put everything in terms of y. The dx is already a dx, so I'm probably just going to stick with this. So I know what y is because I'm given that this is y is equal to x squared. So literally, I just need to replace y is equal to x squared. So x squared dx. All right, now what are the limits on my integration? I want to go from 0, because I'm looking along the x. I'm starting at 0. And I'm going to 3. So the limits on integration are 0 to 3. Okay. And now I just need to perform that integration. So I've got 1/3 x cubed 3 to 0, which gives me, what's 1/3? That's 9 squared, which is 81. No, goodness gracious, no. Let's try this again. 3 times 3 times 3 divided by 3 is 9. Yay. Okay. So the area under that curve is 9. Okay, candy break. Candy break. I think I'm going to have a double stuffed Oreo. Does that count as candy? I don't know. All right, so we'll assume that happened. Okay, now the next thing we want to do is we want to find where is the centroid. So the centroid of this dA, all right, is right here, right? Yes? Am I getting general consensus that y'all are happy with? That's a rectangle, yeah? So the center of this rectangle is at x and y. So x tilde, y tilde. Okay? So the question is, where is physically x and y? Okay. So without too much pain and agony, maybe we can come up with the idea that x tilde is just like this far away. It's basically wherever x is. Wherever x is where x tilde is. So x tilde is just straight up x. And then y tilde, you might say, well, it's just where y is. It's kind of, because this is y tilde, right? Y tilde is this high, except y right now is this high. You kind of smell where I'm stepping. So again, I'm going to try to say this again. This is where your y value is at like this point right here. And we're only half that high up. So we would say that y tilde is equal to the current value of y divided by 2. Okay, for this picture. So for that particular rectangle, the height of the rectangle is y, so the centroid in the y direction of that rectangle is y over 2. Okay, and for me, I don't know why, that was like always the thing that really got me. I was like, what is going on here? And once somebody explained that to me, I was like, oh, okay. So again, what we want to do is we want to say, all right, so we've got x tilde dA. Now, I was kind of working ahead because x is x tilde and dA is this. So I have x, y, dA. And again, I know that y is x squared. So that's basically x cubed not dA, dx. Dx. X cubed dx. And again, the x is going from 0 to 3. So I've got, now I've got 1/4 x to the 4th of going from 3 to 0, and I don't know that off the top of my head. I should, but I don't. So that's 20.25. Okay, so that means that my centroid in the x direction is going to be, again, that strippy strip thing over the total area. So it's the 20.25. I mean, you could theoretically solve the two integrals at the same time on top of each other just to show how awesome you are, but I'm just not impressed by that kind of thing. You know, I'm a sophisticated woman with sophisticated integral tastes. Okay, so the x whatsy-doozy centroid location for that parabola thingy segment is going to be at 2.25. And then to do the y one, I would just need to do y tilde dA. And again, y tilde is given by y over 2, and dA is given by y dx. Okay, and again, I'm just going to be lazy. I'm going to put everything in terms of dx, although I could say that y is equal to x squared, so dy is equal to 2x dx. And so I could say that dy is equal to 2 square root of y dx, so dx is equal to 1 over 2 square root of y dy. I don't want to do that. That just seems unnecessarily complicated when I could just leave everything in terms of x. So y squared is going to be x to the 4th. Yeah, isn't that much better than all of this? Let's pretend that didn't happen. Derpy, 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 derpy. Okay. So basically, I've got 1/10 x to the 5th. Oops, integrating x is still going from 0 to 3 because it's just not that exciting. All right, 0 to 3. So 3 to the 5th divided by 10, 24.3. And so that means that the centroid of the y is going to be shterps to doops over shterp d doops. So 24.3 over 9 noops divided by 9 is going to give me 2.7, which is exactly what I want it to be. So basically, it's telling me that the centroid of this, and it's always a good idea to go look at your picture. See, does my answer actually make sense? So if I look at my picture, does it look like x is kind of at 2.5? Like if I was going to kind of just imagine where the center of this thing was for a second, I'd be like, it's kind of like here-ish. And if you look, that's kind of at 2.25 and 2.7. So, I mean, it smells right. I guess it kind of makes sense. It kind of matches where you think things should be. So, 2.7. So that's good. Now, the thing is you can pick the wrong area. And so that's kind of the other thing I really wanted to talk about in this video. And I know it's kind of long, but you know, it's okay. So picking the right D area can make your life a lot better. So I want to specifically pick the wrong. And by wrong, I just mean like, I don't know. It's just, it needs love too, okay? But But let's just pretend that this is going to be my D area, that I'm going to go this direction instead. Okay? And I'm sure you're already kind of sad about this decision. Okay, so this is dy. Okay? So again, I want to know what my D area is. And you're like, oh, that's easy. My D area is x dy. Not really, because this distance here, well, I know I accidentally drew it at 2. This distance here is not actually x, right? Because this distance here is x. This distance here is stupid 3 minus x. Do you see what I'm saying? Like, you can't just look at it and go, clearly it's x, because it's not. X starts being measured from over here. So x goes this way. So whatever x is, the width of this rectangle is not x. It's 3 minus x. And then the height of the rectangle is dy. So that's usually when you have to start doing weird things. Now, you can't always avoid it though. So that's another reason I kind of wanted to work this out with y'all, to just kind of show you how you move on with life. Okay, so I'm going to go ahead and find dA. So it's 3 minus x dy. And I can go ahead and I'm going to put everything in terms of y's now, because my dy is there. So x is going to be the square root of y dy. And now we got to look at where y is ranging from. Y is ranging from 0 up to 9. Okay? So y is ranging from 0 to 9. And because I'm super good at taking integrals of things, what is that? To the 1/2. So it's the 3 halves, 9 to 0, like that. And it's going to come out to 9, which is not surprising because the answer should not be different because we're doing the geometry from a different direction. So if you just plugged in an x here instead of 3 minus x, you absolutely would not get the right answer. Okay, now this is our official candy break, and we're 17 minutes into this video, and even longer if you've taken candy breaks and actually tried to understand what I'm saying. Okay, I have mini Snickers bars somewhere. Okay. Alrighty, now we're going to look and see, well, where's the stupid centroid? So the centroid of this stupid thing is right here. Okay, so the centroid of that dude right there is, that's going to be the x tilde, y tilde. Now the question is, where does x tilde exist? And if you kind of said a bad word under your breath, I would completely understand. Because, right, this is 3 minus x. So it's actually 3 minus x over 2 plus this x right here. Okay? And so I think this is why I hated this part of calculus. I was just like, what are you doing to me, sir? This is just completely unreasonable. So that's what I'm going to do. So I've got x plus 3 minus x over 2. Alrighty. Now y is actually maybe not so bad, because if you're thinking about, well, where's y? Y is just wherever y is. Wherever y happens to be, that's the centroid. So the y ends up not being too terribly awful. So, okay. So, yay, we're going to go. I'll always be done with this stupid problem to get the exact same answer. We already knew what it was, but it's a learning process because I said so. All right, so I'm going to do the integral x dA, or x tilde dA. So x tilde is x plus 3 minus x over 2. I feel like I should simplify that before I start throwing it into an integral because, I don't know, it just seems like that might be a good idea. So let's say that I had 2x over 2 minus 3, or plus 3 minus x. So 2x minus x is x plus 3 over 2, something like that. Okay, I'm really nervous to do that because I feel like that's something stupid I would really mess up. All right, so x tilde is x plus 3 over 2. And dA, remember, was also obnoxious because it was, where did it go? Oh, it was 3 minus x dy. So 3 minus x dy. You're going to be so sorry that we did this. All right. Okay, and then I'm gonna pretend it's because you don't want to watch me do more math, because I know that you like totally do, because I mean, what else do you gotta do with your time? It's because I recorded the rest of this video with the sound off. Actually, I had it recorded on pause, so I didn't actually record it, but I went ahead and I finished this off. So really from here on, it's just integration. You're just plugging stuff in, you get the exact same answer we got last time, which really shouldn't be a surprise. Same thing here. We're gonna plug in the y for that, what's with me and what's he does it today? Plug in that y for that y tilde. We're going to plug in the dA is equal to 3 minus x dy. We plug that in. We just go nuts with integration, and honestly, we end up with the exact same answer we had before. So this is mostly just to tell you that like I don't know how to say it. Like if you pick the wrong dA, that doesn't mean that you can't get the right answer. And also, quite honestly, there are problems where it'll be like, you know, you have a shape to here, and then you have another kind of shape to here. That's just not a very good example. It's still not a good example, but anyway, like maybe you have like a, I'm not going to say what's he does it. Maybe you have a parabola here, and then you have another kind of a parabola here. And so like whatever your dA is, even if you pick this one, you know, your centroid is going to be just, I don't know, it's going to be in a weird place. And so the ability to be able to say stuff like, oh, it's 3 minus x, but it's x plus 3 minus x over 2, like that kind of skill set is really important when you get to the more complicated looking shapes and structures. So yeah, I guess that's kind of what I want to say. If you can solve these problems both ways, then you know for sure you've got it. If you can only solve it one way and the other way makes no sense, that means you don't understand what you're doing enough. You've got to be able to solve it both ways and be like, okay, I clearly understand why this other method is better, not just because this other method is better because I understand it. Both of the methods need to make sense. It's just that the other one is quicker.